Hello guys, welcome to a new video. And in this new video, we're going to go over section 5 and we're going to go over 5.5, which is firewall features on the Cisco Adaptive Security Appliance, ASA 9.x. And this is for the CCNA security exam. So as you can see right now, I'm almost done. So all I have to do is go over section 6, which is not a lot, and there's nothing that we need to configure, and also section 7, and I do not have to configure anything. I just have to know all of this good stuff, and also this IPS versus IDS and all that good stuff too. So let's go ahead and start with this PowerPoint presentation that I have for you guys. So let's go ahead and start. And as you can see, 5.5 firewall features on the Cisco Adaptive Security Appliance ASA 9.x, which is that means the software that needs to be running on the ASA. And the first thing is the Configure ASA access management. And the access management, whenever you're going to configure the access management, we have done this on my videos before, but this is how you do it, right? You want to go to the interface management 0, and then you're going to name that management, of course, and that's going to set the default to 0. And then you give an IP address, and then you do a no shutdown. Of course, you have to configure the HTTP server, enable it, then give it that IP address um, that you want to be the management on, and then the management access management. So whenever you do this management access, this is what actually gives that management configuration to a zone, or right, like the zone that we gave right here, which was management. So we gave the management access to the management interface. So that configures this management interface to be put into the management access mode. And then after that, you could also configure the username and password. And then we set up the SSH, which is optional. And the way to do it, you should know this by now. If you have your CCNA, you have to do the crypto key generate RSA modulus 1024. You can also double up and do um, 2048, and then you configure the SSH via the AAA authentication SSH console local using the local accounts. That means that it's going to use this Cisco account right here, and then you can create another username if you want, and then you tell which SSH you're going to use. You do version 2, the timeout, which is going to be 30, and then you configure where you want, how, like who is going to be the network that's going to access the SSH, and as you can see right here, it's going to be access for that entire network. So moving on to configure Cisco ASA interface levels, and as you can see, or if you have watched my videos, I have configured the security levels on interface, because whenever I configure the DMZ zone, it automatically goes into 0 by default. So I always put a level of 50 by default. So I always have to do that security level and do a 50 security level. And security levels on interface on the ASA are to define how much you trust the traffic from that interface. Level 100 is the most trusted. So whenever you configure the name if inside, it's going to by default go into level of 100, and 0 is the least trusted. And whenever you configure either a name if or internet or outside, by default it's going to go to 0 because it's not trusted. And some people will use 50 for DMZ, like I use, since you trust them more than the internet traffic, but less than the internal traffic. So let's go ahead and move on. And now we're going to go over the modular policy framework. And this is basically like the CBF or the zone-based firewall that you configure on a Cisco router when you're going to turn it into a firewall. This is similar to it. The configuration is similar, but it is more specific because it goes all the way to layer 7, where you can pick either FTP or HTTP, because when you configure the zone-based firewall, you actually give it port numbers, which is layer 4, and IP addresses, which is layer 3 of the OSI model. But when you use MPF, it's used to control which IP protocols are supported for stateful inspections, and this also does stateful inspection like CBF does. And TCP and UDP inspection is enabled by default and cannot be disabled, so that is enabled by default on the ASA. And ICMP, ESP is not inspected by default, so you have to enable ICMP and ESP to be inspected so you can allow that traffic. And MPF is also used to other purposes, like advanced TCP inspections. If you want to like inspect the traffic to see how big the packets are coming, if you want to limit how big the MTUs are, you can do that by using the MPF. You can also do a deep packet inspection with DPI and also quality of service. Whenever you get a voice traffic, you want that to go first instead of data because um, when using voice or video, it uses UDP, and UDP, if it is a little bit slow, the video could slow down or the audio quality could go bad. But when you're using TCP just to send that data, and if you lose the packet, you are able to retransmit that packet. And also you can do a traffic redirection to software hardware module, which is IPS CX firepower for advanced inspection. So what you can do with MPF is that whenever, let's say that you want to inspect the TCP, and you want all the TCP to be sent to an IPS or CX or firepower, what the MPF can do is send it to that module and then inspect it over there on the IPS CX or the firepower, and then it sends it back and sends it inside to allow it, or if it's going to deny it, it's going to drop that packet, right? And MPF also inspects application layer protocol, like I said, that dynamically assigns ports like FTP. You cannot use a stateless or ACO to allow traffic to FTP because it assigns dynamically port. Therefore, MPF is needed whenever you are going to allow traffic from an FTP server. And here's how it works and what MPF can do for you. So here's, let's say, go to problem number 1. So applications with dynamic port channels or other needs like FTP. The solution is to do an application inspection, and which traffic. We classify the traffic by doing a class map. And what is the action? The action is going to be the policy map that is going to either inspect, or another one that you could do, I believe, I cannot recall. I think it's pass, and the other one is log. And you can also do a inspect and log or a pass and log as well. And the service policy is where to do it, like where you want to do it. That is the where. And also, like we said before, you can do quality of service, rate limiting, policy policing, or traffic shaping needs. You can prioritize uh, police or shape quality of service. And you can do that with class maps, and you can do several actions for several different classes and actions. And for this one, server policy applies the policy to an interface or globally. And if you want to need for IPS or CSC module analysis, it sends the packet to that module, like I said before. And which traffic does, it does it with class map. That's how it classify the traffic. And you can do policy map and service policy over here as well. And if you want to tweak connection settings to a TCP max and to a TCP max form or timeouts, you can. The solution is to change the defaults for those connections, and you do it by classifying the traffic with a class map, and you apply an action, which is a policy map, and where you want to put it is a service policy. So now we're going to describe modes of deployment, which is router firewall or transparent firewall. The ASA offers different modes of deployment. The modes are known as router router mode and transparent mode. The mode of deployment that is used will depend upon your network requirements and needs. The modes of deployment have the following characteristics. So router mode is when the ASA supports RIP or SPF, BGP, dynamic routing protocols to integrate into existing routing infrastructures. And where dynamic routing is not available, the ASA can use static route tracking to determine neighbor or path health instead. This is the most common use mode of deployment. This is the one that I use all the time, where I configure a static routes always. I have not done any OSPF, EIGRP, or BGP, which is I'm going to do on another video. In transparent mode, I have not done this. Transparent mode or bridge mode, the ASA includes the ability to operate in a secure bridging mode as a layer 2 device, okay? Layer 2 device, so it's going to be inspecting MAC addresses, right? And this is to provide rich OSI layer 2 through layer 7 security services for the protected network. And this ability enables businesses to deploy security appliances into existing network environments without requiring readdressing of the network. Although the security appliance can be invisible to devices on both sides of a protected network, you can manage it via a management IP address, which can be hosted on a separate management interface if required. And now we are moving to the 5.5F, which is the criteria methods of implementing higher availability. And we have different availabilities, which is active and standby. And this one only one firewall works and passes traffic while the other remains in standby. Active standby failover can run on a single or multiple context mode. Active is when both firewall work and pass network traffic. Firewall the firewalls the firewalls must be running in multiple context mode. And we have active state failover, and IPsec or SSL VPN cannot be enabled. Firewalls must be an ASA 5510 Security Plus or higher base. And here are the requirements for a failover. So the firewall must be the same model, number and types of interfaces. The firewalls must have the same amount of RAM installed. The firewalls must have sufficient free space on flash for ASA image files and configuration files. The firewalls must be in the same mode, router or transparent mode, single or multiple contacts. Firewalls must have the same numbers for major and minor versions numbers. So they need to match all of this for you to be able to implement a high availability. And here is the requirement, like I said. Um, you need the same model number and interfaces, same amount of RAM, free space, and same mode, and also the same version for major and minor numbers. And here's a picture of a active and standby. As you can see, only one file over here is going to be working 100%, when the other one is going to be on standby. But if this one goes on standby, then this one is going to work 100% of the time. So if one fails, the other one takes over, and just that's how it works with the active and standby. And like I said, active failover model. Both security appliances can actively process user traffic and can tolerate the failure of one of the devices in the failover cluster. This example is somewhat more complex and introduces the concept of security contexts. Three security contexts are used. Failover group 1 should contain the admin and context B context, with the primary ASA normally having the active role. Failover group 2 should contain only context A, normally active on the secondary ASA. We will discuss security later on. And here's how active works. Here's a picture of active, and this when you do like a 50-50, they do a load balance, so they take both firewalls um take on the data. So this one's going to be 50% and this one is going to be 50%. But if one of them breaks, then the other one's going to take over 100% for the operation. And another one is clustering. And this feature lets you group multiple ASAs as a single logical device. A cluster provides all the convenience of a single device management integration into a network while achieving the increased throughput and redundancy of multiple devices. These interfaces connect to two different switches, which are connected using a virtual port channel (VPC) 10 gigabit 06 and 07 interfaces on both cluster members bundle into the inside Ether channel. So it is like an Ether channel. Both, if you guys remember that from the CCNA, if you took the CCNA, and both members respond to the virtual IP address of 192.168.1.1 on this link. 10 gigabit 08 and 09 interfaces similarly bundle into the outside Ether channel with the virtual IP address of 172.16.12.12.125.1. And here's the picture that I was describing over here on this clustering. And this is how cluster works. As you can see, we have two firewalls, firewalls, working together, and they are working like it is just one firewall working um, at the same time. Like you do not see two firewalls. What you see is only one firewall because they are combined together to work as one firewall. And this is how you can configure that cluster, ASA cluster. And then to describe the security context, you can partition a single ASA into multiple virtual firewalls that are known as the security context. Each context is an independent firewall with its own security policy, interfaces, and administrators. Having multiple contexts is like having multiple standalone firewalls. You must first configure the security appliance that will host multiple security contexts into multiple mode to support virtualization. Most of the single mode Cisco ASA security appliance features are also supported in multiple context mode, including static routing, select dynamic routing protocols, access control features, security modules, and management features. And here's how the virtualization of a ASA works. It kind of works like if you are, it's kind of like virtualizing an ASA to work has to, it's like virtualizing, it's like a virtual um, firewalls that you can configure over here, and then you just have an admin where you can control all of these firewalls. So you're going to have these two basically like clients, and this one is going to be the admin that from where you can control all three of them. And this is it for this video, guys. I hope you guys enjoyed this video. I know it was a lot of talking, nothing to configure, but it's all good because we have a lot more configuration, a lot more labbing coming up. Since I do not have any more labs to do left, because we did all the labs from 1.0 all the way to the 5.0, and I know that 6.0 and 7.0 do not have any labs that we need to do. I'm still going to be labbing from the security access, VPNs. We're going to do secure routing and switching, and also some Cisco firewall technologies that we're going to be labbing, so we do not forget those. So when we take the exam, we can ace that exam. So thank you guys for watching, and I'll see you on the next one, guys. Bye bye.